Hello friends, today we'll discuss about Sommerfeld's model and azimuthal quantum number. Now, in order to explain the fine structure or multiple structure of spectral lines, Sommerfeld modified Bohr's theory. Now, what is fine structure? If a spectral line is analyzed by a high resolving spectroscope, we found that a single line is actually composed of more than one line, which are very closely spaced. This is called fine structure. Now, in order to explain the fine structure of spectral lines, Sommerfeld modified Bohr's theory by stating that the electronic path is not circular, it is elliptical. That is, the electronic path is not circular, it is elliptical. Now, only those ellipses are selected where the ratio of principal axis and major axis and minor axis, length of major axis by length of minor axis, length of major axis divided by length of minor axis is equal to n by L plus 1, where n is principal quantum number, we know that, and L is azimuthal quantum number. Value of L varies from 0 to n minus 1. This is L. Actually, L varies from 0 to n minus 1. N is principal quantum number and its value is, we must remember that all elliptical orbits are not possible. Only those elliptical orbits are possible where length of major axis divided by length of minor axis is equal to n by L plus 1. That is, some quantum mechanical restrictions are imposed. Actually, in this way, we can state it that each principal quantum level is composed of subsidiary energy levels or azimuthal energy levels. These azimuthal energy levels describe the shape of different sub-energy levels present in a principal energy level. And due to presence of this sub-energy level, when electron jumps from higher energy orbit to lower energy orbit, instead of getting one spectral lines, we get multiple structure or fine structure of spectral lines. That is, more than one number of spectral lines are obtained. Now, we discuss about the shapes of different sub-energy levels. As for example, if n equal to 4, what is n? N is principal quantum number. Then L equal to 0, 1, 2 and 3, because value of L varies from 0 to n minus 1. So L equal to 4 is not possible. We should remember that when L is 0, it is denoted by S. When L is 1, it is denoted by P. When L is 2, it is denoted by G. And when L is 3, it is denoted denoted by F. So, 4 types of sub-energy levels are possible with principal quantum number 4. That is 4s, 4p, 4d, and 4f. Actually, 4f is circular. 4d is elliptical. 4p is more elliptical. And 4s is its ellipticity is highest because length of major axis by length of minor axis, this is equal to n by L plus 1. Now n is 4, and for F sub-energy level it is for F it is 3, so 3 plus 1, that is 1. That means length of major axis by minor axis is equal. So 4F is circular. For 4D, the value is 4 by 2 plus 1. That is, the value is 4 by 3. So major axis is greater slightly than minor axis. So it is elliptical, but not too much ellipticity is there. In case of 4P, the value is 4 by 1 plus 1. 1 because P, for P, L is 1. That is, it is equal to 2. Ellipticity is more. So 4P is more elliptical. And 4S, it is 4 by 0 plus 1. That is, major axis is 4 times greater than minor axis. So its ellipticity is maximum. So sub-energy levels, different sub-energy levels, their shapes are different. All the 4 sub-energy levels belongs to same principal energy level 4, but their shapes are different. And due to presence of these sub-energy levels, we get multiple structure of spectral lines. Now, the angular momentum or orbital angular momentum of electron equal to root over L into L plus 1 into h by 2. L is azimuthal quantum number. We actually discussed it. And h Planck constant, pi is 22 by 7. So angular momentum or orbital angular momentum of electron can be calculated easily. Now, actually, if we synopsize the whole thing, Sommerfeld's model is required because to explain multiple structure of spectral lines, and to explain the multiple structure of spectral lines, it is considered that the shape of the orbit is not circular but elliptical. Only those orbits are selected where length of major axis by length of minor axis is equal to n by L plus 1, and this L is called azimuthal quantum number. Azimuthal quantum number L, when 0, it is represented by S. When L is 1, it is represented by P. When L is 2, it is represented by D. And when L is 3, it is represented by F. If one asks that if a question is there, 2D possible? 2D possible? So the answer is that 2D sub-energy level is not possible because here n is 2. This is n, value of n. And D represent L equal to 2. Now we know that value of L is always less than n. Actually, L is 2 here. Actually, L is 2 here. If the principal energy level is 2, azimuthal quantum number cannot be 2. So 2d sub-energy level is not possible. Similarly, if a question is there, 1p is possible. 1p is possible. The answer is no. Because here n is 1, and when n is 1, L is always 0. L 0 means S. So 1s is possible, but not 1p. So 1p sub-energy level is not possible. 2d sub-energy level is not possible. 3f sub-energy level is not possible. 3s sub-energy level is not possible. This is all about Sommerfeld's model and azimuthal quantum number. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.